Okay, so now we're going to talk about a mixture problem. Now, mixture problems, a lot of times they'll use different types of solutions that they're mixing together. Maybe you have like a 30% saline solution and you have a 50% saline solution. So you're going to mix them together and you're going to get, depending on how much of each each solution you have, you're going to get somewhere between a 30% and a 50% solution. Maybe you're trying to get a 40% solution or something. Anyway, this is the type of mixture problem we're talking about. Now, you can also have mixture problems like you're mixing types of nuts to make like a mixed nut mixture. Or coffee beans. You have a high grade coffee bean and a lower grade coffee bean, and you're mixing them together to get this blend that's going to cost, somewhere in between. Okay, so we're going to be doing, though, a percent solution problem. So what happens is if I have a 30% saline solution, let's say I have 50 milliliters of it. Okay, so the amount of salt, that's the saline, that's going to equal 30% of 50. Okay, that's how much actual salt I'm getting out of that saline solution because 30% of it is salt. Okay. Um, Now to figure that out, you have to make the percentage into a decimal and you multiply it times the amount that you have. So that would tell you how much salt you're getting from that one. Then let's say you have 70 milliliters of the other solution. So the amount of salt would be, so the amount is going to be 50%. It was 50%. You can't see that. It's 50%. So you're going to make that 0.50 times the 70 milliliters. And then that's how much salt you're getting from that one. Together, it'll tell you how much salt you have, right? Okay. Now, that's the idea behind these mixture problems. So I've always done the mixture problems with a chart. I think I learned this in high school. I don't remember, a long time ago. And it's a 4x4 chart. Okay, well, maybe 4x4. Okay, so there's a percent. There's how much. Okay, so in this case, it was milliliters. And then there's the amount of, chlorine or salt or iodine, whatever you have in your solution in. Then you're mixing two things. So number one and number two, whatever your two things are, thing one and thing two. Okay, so you fill out this chart, and then down here, you're going to have a total. Now this, oh, we do need that box. Okay, so there you go. That's how the chart's kind of set up. Now it doesn't have to be milliliters, but it could be cups. It's going to be some kind of volume, gallons, quarts, something. Okay, so here we go. We're going to set up that chart again. I'll draw it again. And if you fill out the chart, it works out really nice. Okay, so a chemist working on a flu vaccine, I think, needs to mix a 10% sodium iodine. Okay, so sodium iodine. So sodium iodine. And it's a 10%. So that's going to be 0.10. So 10%. So your percentage, I'm going to put that in the first column. Is that what I did? Okay. Oops, sorry. So we're mixing a 10% sodium iodine with a 60%. Okay, so here's the 60% one. And then, so that's going to be 0.60. So change your percent to a decimal, okay? And in the end, so this is like the total in the end, or you can put end result if you want. Sometimes I put that. We want to obtain 50 milliliters of a 30%. So we want it to be a 30%, and we want 50 milliliters. So it is milliliters. How many milliliters of the 10%? Okay, we don't know. And of the 60%, we don't know. That's our X and Y to get that solution, to get this to happen. Okay? So here we go with the amount column. You multiply across. So multiply this way. So it's going to be 0.10x That's how much sodium iodine you're getting from that beaker. You know, you're mixing like two beakers. It's like you have a beaker 1 and a beaker 2, and you're going to mix those together and form this new solution. And there's going to be so much of it. And depending on your mixture, have a certain percent sodium iodide. Okay. So the amount you're getting from the first beaker, that's like this top row, 0.10 times X. The amount you're getting from the second row is going to be 0.60Y. Okay, and then how much actual sodium iodine do we want in the end? We want 30% of 50. So we're going to have to multiply that out. Now, you add going down. So you multiply across and you add going down. So if I take X milliliters plus Y milliliters, it's got to add up to 50. Okay. So I want a total of 50. So maybe I want 30 and 20, or maybe I want it to be 25 and 25, or 10 and 40. We don't know. That's what we're going to figure out. Now the second equation comes from this column. We want to be able to take how much sodium iodine from the first beaker plus how much sodium iodine from the second beaker. That has to equal how much sodium iodine we have in the end. Okay, so that's how the chart works. That's what I've always used. You might find something similar in different textbooks, but that's just what I've always used. And you can think about it. You can read the book and see how they do it. Might make more sense to you. But that's how I've always done them, and it's always worked for me. Okay. So now I have two equations and two unknowns, an x and a y. It's a system of equations. Okay, so there's a couple things I can do to make things better. First of all, I can, let's see, I can figure out what this 0.30 times 50 is. Okay, so let's do that first. And then what's 50 times 0.3? Oops. 15. Okay. Now, I usually don't like the decimals, so I'm going to go ahead and multiply by 100. You could say, well, you don't really need those zeros. You could do it a little bit different, but it's not going to make a big difference. So 10x plus 60y equals 1500. Okay, great. So that equation looks a little better. It doesn't have the decimals in it. I can work with that. My other equation is the x plus y equals 50. Now, that's a great one for substituting. So I haven't done a lot of substituting problems. Usually I do these with addition method. You could multiply by a negative 10, and it would work just great. You can do it that way. So that's kind of up to you, but I'll do it substitution. So let's say I subtract x, and I rewrite this equation as y equals 50 minus x, right? So bring the x over. This is one way you could do it. And I could substitute that in for the y. So I have 10x plus 60 times 50 minus x equals 1500. And then I can solve 10x plus 3000 minus 60x equals 1500. I think I should have done it the other way. Okay. So what do I get? Negative 50x plus 3000 equals 1500. So subtract the 3000. You have to be careful with your signs and stuff. I think this is all going to work out good. So if you get some crazy answer, you'll know, and then you'll be like, what happened? And you have to go back and check your math. Divide by negative 50, and you get x equals, I think it's 30 milliliters then. That seems reasonable. Okay, so we need 30 milliliters of, now which solution was x? X was the 10%. So I need 30 milliliters of, and you're going to have to, when you write your answer, you're going to have to say which one's which. So of the 10% solution, I'll just put sodium iodine. I should have put solution iodine. And then if I need 20 milliliters and I'm sorry, if I have 30 milliliters of the 10% and I want 50 altogether, then I need 20 milliliters of the 60% sodium iodine solution. Okay, so that's the answer right there. Okay, so mixture problems are fun. Uh, I don't usually do the substitution method. I usually use the elimination method, but you can pick which method you like. Both are pretty reasonable to use.